John. So what are we going to be looking at today?
We're going to explain the history of the SG machine.
Okay.
And and the three modes of operation that's never been explained on the machine. So if you want to come around here, this was the kit that we built, and we only made 10 of these kits. So, and this SG is built just a little bit different. You notice it has two fans. That's to slow it down more with wind drag and to sort of change what the triggering's doing. There's also 9 winds on the coil, and it's wound in the counterclockwise direction. In other words, so the motor is in a traction here, or the energizer, which way you want to term it. Most people say motor, I say energizer. But, and they're all north poles, facing out. And there's 21 magnets around the wheel, so there's an odd number of magnets around this wheel. All right, so what I want to do is on this side is the primary battery, and this is the voltage on the primary battery. Now, normally, batteries will stand around 12.65. And this is going to be the secondary battery. And what's on the computer screen is we're going to take 1 amp hour out of this battery. And then we're going to put it back by showing the 3 modes of operation on the machine. So, a little bit of history. The actual year was 1955. And I always had a fascination of taking a DC motor and running that motor and hooking it to some form of generator. Because I always thought, well, you know, if I hook it to a generator, and I'll just abbreviate it, GEN, that I could put this back to the primary battery. In other words, the battery out here. I always thought that, well, you can run the motor. And remember, a kid's thinking this.
How old were you?
That's not very old, maybe about 9 or 10 years old. And so I always thought, well, you can take this motor and hook it up to the battery, and the motor starts running, right? And of course, not having any basic engineering, but just being a typical kid, in a kid's mind, right? He thinks, well, that's possible.
It's simple, right?
Yeah, it's very simple to do. Right, so when I did this, here's what happened. So the motor's spinning at 3,000 RPMs or whatever it is, drawing power from the battery, and I'm saying to myself, okay, I can make this continuous thing, right, and run it back to the battery. However, everybody knows exactly what happened here. The generator tried to put the energy back to the battery, but then the motor drew more current, and so it slowed down and slowed down and slowed down until there was no more generator. Years went by. I mean, I thought about this for a very long time. And I said, there must be some way to do this. So, but in the meantime, what I was doing was I was experimenting with this motor. And I found out that if you put a capacitor here, and at that time, I think the biggest capacitor that I could get was like 3,000 or 4,000 microfarads. That this would charge up to like double the battery voltage. All right, so if this is, at that time, I think this is a 6-volt battery, so it would charge at 12 volts. So I found that if I broke the positive line, right, and put a push switch here, push button switch, that I would wait for the capacitor to charge up. And meanwhile, there's no load on the generator, so it's not drawing very much current, all right, in amperes, because at that time motors weren't very efficient, maybe 40%, 30%, and maybe this was 1.2 amps. And I found out that that you would let this run, and you would watch this with a meter, a voltmeter, and when it got to 14 or 15 volts, or whatever voltage the generator put out, that the cap could charge to, which was basically double the battery, so 12 volts. You'd push the switch real quick, and you'd see the deflection on this amp meter and the deflection on this amp meter in amperes. And what would happen is you'd hear the motor speed up for just a second, and then you would let it charge back up, and then you hit the switch again. All right? So for years and years and years, and by that time I was in the military, and I was still thinking about this the whole time. How could you make this all work to where you have a motor or because the generator is going to become an energizer when it's free from its drag.
What do you mean by energizer?
Energizer. In other words, it's just a potential. There's no current involved. So there's just a high voltage here. Okay? And it's being captured by this capacitor, which is charging, and then the discharge is current. So because you're storing the energy, you have really no current here. You're not trying to drag this generator back down. You're just charging this capacitor, and then you're pushing this little switch. And then you're discharging whatever's in this capacitor back across the primary of the storage battery. Well, that worked to a certain point, but how long were you going to sit there and push the switch? So what I did was I came up with all kinds of schemes in my mind. That's what, young people do. They always come up with a scheme. So I decided what I was going to do was I was going to take this DC motor. And I thought about this while I was in the military. Of course, I was going to school in the military to do, top secret communications work. And I was stationed to a base in Germany, in Gerplingen, Germany. And that base had some interesting little things that I really can't talk about. But some of the things that we do was a cleanup. And this was underground. And so...
A cleanup of what?
Yeah, cleanup of whatever was left over from World War II.
Nazi Germany stuff?
Yeah, Nazi Germany stuff. And so there were batteries, and there were, motors, and there were generators, and I sort of got inspired, but I didn't have any time to actually work it out.
Yeah.
I couldn't work it out.
Was the German stuff pretty good?
Oh, yeah.
Yeah.
Yeah, the batteries were kind of interesting. They were mercury batteries, and you could turn a little handle on them, and it's like they came back to life. So that's as far as they can go with that. But so what I thought about was during this whole time was taking this motor And I really couldn't wait to get back and do this. And again, we had the DC generator and the DC motor and the shaft that was coupling these two. And of course, this is spinning this way. And so what I thought about was a scheme. I thought about this scheme about, okay, let's do this. Let's take the DC motor and take a commutator from another motor and put the brushes on the motor, on the commutator. And of course I was going to have to start this by hand because this always didn't end up across the two contacts. And so this is what I did, is I took the battery, which by that time was 12 volts. So this is now 12 volts. And the way I hooked it up was this way. So we're just going to call this plus, this minus. Okay, and now I had a contactor. So now I've got a primary battery, right? And I had to give the motor a spin, so I would sit there and you would take your hand and the shaft, right? And of course it would make contact, right? And then the motor would be pulsing while it was running. And then I thought to myself, well, I don't want to run back to this battery unless this is off, because if this comes back to this battery and this is on, then I've defeated my purpose, because all the energy is not going to go to the battery. It's going to go back into the motor. So there, a young man learns that there is no perpetual motion there. All right, so then I thought to myself, what if I just take the generator and make another contactor and make the other contactor so the brushes are this direction while these are this direction, and leave these brushes the same, like that.
So do these spin?
Yes,
Okay.
they're on the shaft.
Okay.
All right. Everybody knows what a motor commutator, well, maybe they don't, but a motor commutator has segments in it like this that the brushes make contact with.
Okay.
So actually there's a hole there, and this commutator is on the back of the shaft in the motor, inside this motor.
So it's spinning around and
Yeah.
contacting the brushes. Okay.
Yeah, it's making its contact inside here, but now this is saying, we don't care if this has contacts all the time. We're only giving it power part of the time. Mm-hmm. All right, just however many segments are making contact at that time. All right. So, what is this saying? That current's only flowing when this is contacting. So we're only using energy from this battery during this connection period. Now that's time. It's how many of these brush segments did I wire together at that time. And see, the segments would look like this, and then they're all wired together. And that's actually making the switch because it's shorted together. So there's a wire that's going from this one to this one. Actually, I should put that in red so you can see this. But now I want you to understand, I want everybody to understand out there that this has taken 20 years.
Yeah.
You know, you're going through your thinking all the time. You got this fascination in your mind that you think you can do this. In reality, every book is going to tell you you can't do this. So, once again, the wire's in here, so that's in the red. And once again, the wire's in here, and that's in the red.
But John, I don't understand. If those things spin,
Well, they're spinning on this shaft.
yeah, then why does it matter if the ones in this ones that you haven't got connected, that they're at
Well,
90 degrees to the other ones?
these are there, but they're not connected. In other words, they're not connected to these. These segments are connected together and the other ones are separated. In other words, the motor commutator looks like this, and the coils of the motor go between these commutators, like this. You see? All the way around.
Okay.
And they form the loops of the motor. All right? So when you energize the motor, these become magnetic fields against the permanent magnets.
Okay, but
So it's this, Pat. Look. It looks just like this. It's a rotating loop. And the brushes make contact with this loop, and the magnets are out here, north and south. And so when they make contact, that spins away. It's in every textbook.
But I still don't understand those two spinning bits. Why?
Well, I connected the motor to the generator.
Okay.
But as I said in the beginning, that when I did that, okay, without this arrangement, right, that this was drawing continuous current. And if I brought this back to the battery, this was drawing much more current until the thing just slowed itself down and didn't generate anything.
Yeah, but my question is, are these spinning independently or?
No,
are they
they're
fixed?
connected together. They're
They're
fixed on the
in-
shaft.
Okay, so that's, I was thinking of
Right.
each going to.
So if we're
Right.
looking at it, right, let's just say we can look through the two that I had,
Okay.
right? What you would see is this.
Okay.
And I would call these two A and
Okay.
these two B.
All right.
So now there's a phase difference, isn't
Yeah.
there?
Okay. Now I understand.
Okay. So I thought about this and I said, well, I still need to charge this up, right? Because what I wanted to do was I didn't want to go back to this battery. I wanted to go to a second battery. Okay? I wanted to use the power from this battery to run things. And I didn't want to use that much power from this battery while this was recharging this battery. So see, if you look at this, you follow it through, if this was plus and this was minus, we charge the capacitor, right? We get a big charge. Now we're up to 24 volts because that's what it has to do because it's a generator, all right? It's got to excite itself and then the high voltage and the sparking and everything. And we learned that about sparks. When you have a pulse and you have a spark, right, you get this high peak.
Yeah.
That's 300 volts. Typical of what we're going to get into here. So now we go back here. I don't have to push a switch. I give it a spin. And the next thing I know, this is charging and it isn't draining this battery that much. So that was this concept of somebody that was thinking about all this these years, but still that wasn't good enough because it has to really be more efficient than this. This is 40% if you're lucky, and this is whatever. And it has to be spun, right? But remember what's happening here. The motor's spinning, making contact, right? And the motor gets a pulse, goes forward. Well, little to my surprise, I didn't realize that that pulse, when this arced, that could have been captured too and sent back to that battery. All right? But I'm jumping ahead of myself here, and I don't want to do that. I want everybody to understand what my concept was in the beginning with all this.
Yeah.
And that was to always have a DC motor drive a generator and be able to either recharge the primary battery, recharge the secondary battery. So, here we are. 12 and 12, two equal things. All right, but now this one's charging, and it's charging like this, and this one's going like that. Mm-hmm. So that quite doesn't fit, right?
Yeah.
See, because this is not efficient here. It's being wasted, and nothing's coming back from it, right? Now, if we could have captured everything that this one was wasted and put it back to this one, we could have probably had a curve that did that. But I didn't know any better. And I was, even though I had all this schooling for radar and everything, I still had this. I didn't want to believe what they were teaching me. I wanted to believe in my own mind that this was possible to do and that you could do it and you could make a machine that would do it. So, this is where I got. This is how far I got. Okay, and years went by and I didn't do anything about it. I thought about it, I saw how it was charging, and you know, when you don't do something about something, you just sort of lose the whole concept of what the machine is. So, okay, so anyway, Pat, let's back up in time again. And let's take the little kid in 1955 or 1956 or 1957 that's attending middle school.
Yeah.
He's full of questions. So if you approach the blackboard, right, and you ask the science teacher, gee, I had this motor, this DC motor, and I want to run the motor with this battery. Like that, right? We know that when the battery runs, at that time it was 6 volts, so we know that when this battery is depleted, that motor stops running.
Right.
Okay, so you question the teacher a little bit further, and you say, okay, but I'm going to hook a generator to it. All right, and I'm going to run this generator back to this battery. And of course, the teacher that's 30 years old at that time, right, is laughing.
Sure.
Because he knows better, right? And he tries his best to not hurt your feelings. Right? So he says, well, John, you know, that couldn't possibly work because the motor's going to slow down, and then the generator's not going to generate, and then it's just going to stay at this one speed where the two of them equal each other.
Yeah.
Okay? The same thing a DC motor does. If you let it run wild, it gets up to its rotational speed, and then it becomes a generator. Ah! John is thinking to himself. But in the meantime, John is got a book that of course was written back when, and that book was The Boy Electrician by Alfred Morgan. And of course in that book you can build your own batteries. So I did that. You know, I actually went to the hardware store. You could go to the hardware store and buy radium paint.
By what?
Radium paint.
Oh, okay, yeah.
Yeah, and you know that they painted watch dials.
Yeah.
And so in here, it showed you that you could go to the junkyard and buy a 6-volt battery here. And with a little bit of work with charging and discharging, key number 2, but I'm not savvy enough to get...
You're not there yet.
Yeah, I'm not there. And with a little work of charging and discharging, you might, if you're a lucky kid, be able to restore this battery to be usable, right? So I go and I get a junkyard battery, and I get it. And at that time, I think Pep Boys sold a 1-amp charger. That's all I could get on my allowance,
Yeah.
right? Because I was doing yard work for like a quarter or 15 cents. But I was saving my money, and I was very interested in doing this.
Right.
So I finally got my dad one day to take me down and get me some lead, because lead wasn't harmful then. I mean,
Hold it up.
hell,
Hold that up.
they painted the cribs with lead,
Right.
and you ate lead, right?
Hold
So,
it. Okay.
so I built this battery. I actually built this battery the way you see it here. I went and got the red lead from the hardware store. It was in a can. And I pasted the plates, like it said. I mixed it with sulfuric acid. We didn't even know that sulfuric acid was dangerous. Right? We didn't know any of this was dangerous. And they weren't saying that it was dangerous to you in this book. They were saying the kid that had the initiative. See, what this is all about is initiative.
Yeah.
Right? You got to have an idea before you can create something. All right? So here I do that, and I built all these projects, Pat, in this book to see if what I actually built this machine to wind coils. All right? Which is a hand crank and a spool. Beeswax I had a little bit of trouble with because I couldn't find it. Today you can find it.
What do you need beeswax for?
Well, I needed beeswax for the coil.
Oh, okay. Yeah.
You know, because everything, when I was building the Tesla coil, I used beeswax because, you know, it sort of insulated the coil. It's almost like
Go
coil
to the
dope.
work store.
Right, but I actually built this motor right here. And if you look at this, right, it shows you the commutator segments.
Yeah.
So let me,
Just hold that.
yeah.
Hold on. Yeah. Got
See, it says put a paper core here, and then you're putting the wires across here. So you're making a commutator segment. And then you're putting the see, you're winding a coil. See, and it's showing you the commutator there.
Yeah.
Great book.
Yeah. Especially for somebody that's in, you know, 2nd or 3rd grade.
Yeah.
That's interested in this. I mean, I'm sorry, but I was interested in it. I actually built this generator. I tried both these things. I said, well, if you can build a small one, you can build a big one, right? It was much easier, though, to go and get 2 fan motors from a junkyard,
Yeah.
right? And so I built all these, and it showed you how, I actually made a train, Pat, like it said in here. And I learned all these circuits about switches and things like that and how to build these lights. And to me, though I have to be honest with everybody that's viewing this, this was not fascinating. This left me with a lot of questions about this. So, I want to go a little further, and I'll get out of this book now.
Okay.
And we'll go back to this. So, years went by, and it wasn't until probably 1978, that I started experimenting, because by then, transistors were a lot bigger. But they were germanium transistors is all I could get. And they were a very odd looking transistor. Some were in radios, and they were very big, and they were PNP transistors, and they had, when you looked at them, they had a big top like this on them, right? And they came down like this, and they had a stud on them. And then they had, 2 leads.
What's a PNP transistor?
Yeah, it's a PNP transistor was,
Positive, negative, positive.
yeah, positive, negative, positive.
Okay.
And
PNP.
and they were Motorola devices.
Mm-hmm.
And they weren't very powerful. I mean, they used them in the car radios, maybe, a couple of amps or something like that. And I kept saying to myself, I got to learn, about this device more.
This was in 78 or 60?
No, I'm saying when this came out, then I
78.
knew
Yeah.
what to do. But what I'm saying is back then, when I first seen the transistor, which was this little thing, with 3 little lousy leads coming out of it, and it had a little top hat on it like that.
Right. Okay.
Right? And it was E, B, C, and like that, right? Where this was C, B, E. See?
Yeah.
So this was a power transistor, and this was a signal transistor.
Okay.
And back then we experimented a little bit with them, and of course you could make germanium radios and things like that, where you could, you didn't need much power to run that thing at all. And anyway, as time went on, and I got into the amplifier business and was learning, working with power amplifiers and things like that, we started working with more powerful devices. And of course, at work one day, kind of hate to say this, because, when you're goofing off at work and you're not doing your work, and you're thinking about something and you're doing a G job on the bench, you don't want to get caught. Right? So I thought to myself, okay, I got this nice TO3 power transistor, and of course a TO3 is one that's sort of shaped like this. All right? And it's, the case is the collector, and then of course you got a base and an emitter lead coming out of it.
Yeah.
All right? I said to myself, well, to me, what is this? All it is a switch. You put the power into the base, and the switch closes. On and off, on and off, on and off, on and off. And it could go fast, right? So I said to myself, why not develop something that can use that switch?
Yeah.
All right. Meanwhile, I was building these power amplifiers and doing this and working for electrophonics industry, doing their little amplifiers and whatever that they were doing in San Francisco. But I always kept the concept of what I need to do is I need to build a motor that turns on and then has a little bit of rest in it, and then applies the generator back to the battery, has a little bit of rest in it, and then applies the motor again, and then the same thing is repeated, right? Because I was still thinking single battery, one battery.
Yeah.
See, it's not important if it's one battery or it's two batteries, because the energy has to go somewhere. Okay, so anyway, I kept thinking to myself the whole time, we got transistors and they're switches. And this is what I need to do. I need to turn on the motor and then turn on the generator and then turn on the motor and turn on the generator, right? So in my mind, I was thinking, I need to have something to demonstrate that I can get this pulse motor to run, not draw very much energy, and be able to have something that I can pick up as a charge. So what I came up with as an experiment was to just make what everybody knows as a pendulum. And I said, I only need one pole, because why do motors need two poles? That's just a waste. Every time the brushes go by the commutators, you get this arcing. Of course, they solved that, in the later years, but right now I had my own thing to solve. So what I did was I wound a bifilar wound coil. And what that means for everybody is it was two coils. It was actually two coils.
Two wires.
Yeah, at the same time.
Right.
Now you have the same number of
So you wind two wires,
Yeah.
at the same time you wind up with two coils.
Yeah. And then of course it had to have iron, because when the coil turns on, it has to move the magnet, which gives it the motor action. So I said, well, I got these transistors, and what I'm going to do is I'm just going to hook this transistor up. By that time, we had silicon transistors, which were pretty rugged. All right? And I said to myself, I just put the battery at this end, the plus, to the top of the coil, and the minus back to the emitter. And so I experimented with a single coil at first. So if I remove this coil,
So you don't have a bifilar.
yeah, so I don't have a bifilar coil. I experimented with this first by taking a resistor and just coming from this portion, right, like this, and then I put it on a switch, and I would hit the switch, and of course the pendulum would go that way, right, or whatever way it fell, it would go either way, because it could only swing either way. And so I says, well, there's a better way to do this, and that's have it turn itself off and on, right? And so the way that I started out was I started out with a 10 ohm resistor, and then of course that when you give it a push, then that it's going to generate. And so that little bit of generation energy would turn that transistor on, and it wouldn't use very much. Okay, so I started out with a pendulum, with this exact thing, and I studied this. So if I give the pendulum a push, see, each time that it turned the transistor on, it gave another push, right? And pretty soon, I have a motor.
Right.
Is there a battery in there?
Yes.
Yeah.
But it's been in there for like 8 years or 10
Okay.
years. Yeah, and so this was the exact circuit that was in there.
Mm-hmm.
We weren't talking about, we weren't doing anything by trying to conserve any energy at her at all.
Right.
We just wanted this action. We wanted this motor action. All right?
Mm-hmm.
So, and by the way, it'll keep speeding up until it reaches the level of where the wind drag and the electromagnetics, and that's all it's going to move. And actually, it's pretty well balanced because it ain't vibrating out there. So anyway, that was the basic concept of what everybody would term the SG.
Mm-hmm.
So basically, yes, there is an SG pendulum just running into motor action without any recovery or anything. So the next serious problem with the SG, which everybody terms the schoolgirl motor, is that we have to recover the energy. All right. I've basically tried to give everybody a concept
Right.
of what I was after. It's something that never left my mind. Because I've always wanted to strive to make this happen. All right. So we saw the basic theory of the pulsed pendulum, which turns into a motor and gives you a motor function because it's triggering that transistor on each time. All right. So later on, I said to myself, I want to take this further, and I just want to make a wheel with 4 magnets on it. And of course,
So what prompted you to do that, do you think?
because I wanted a motor action, I wanted something that gave mechanical energy
Okay.
along with the recharge capability of the two together.
So there wasn't a magnet in here?
Yes, there's a magnet
Okay.
in the pendulum. All right, so I said, remember, if I back up just a little bit, I said, why do I have to switch poles?
Mm-hmm.
Why do I have to have a north, and why do I have to have a south when that's not necessary? I can just have either a south or a north.
Yeah.
So I chose north. And I made the same coil again down here. Like I've shown in the beginning.
Mm-hmm.
And of course I used the same transistor. Okay, and this is basically function 1 of the SG. All right? And of course everybody calls it the schoolgirl motor. Actually, the reason that they call it that was because Shawnee Baughman won the science fair with this exact pulse motor.
Okay.
Except that Shawnee Baughman figured, I'll put a coil up here and light a LED
Okay.
as the magnets go by. So she did basically have a motor that was pulsed and a generator.
Mm-hmm.
You know, at a very small level, but she had it, didn't she?
Yeah.
And so anyway, if we take this off, I just wanted to clarify that a little bit. And you put your battery here. You now have, once you get this set up, remember when I started, I just had a resistor. I didn't think anything about anything because I wasn't trying to recover anything. And as time went on, I found out that as I added more voltage here, I started with a 1-volt battery, 1.5-volt battery, and then I went to like 6-volt battery, and then I went like to 10 volts of batteries, and I went all the way to like 24 volts. And each time I exceeded the 12-volt level, the transistor would blow up. So I was sort of stuck. And I said to myself, so I started watching signals with a scope. By that time I had my own scope, because I was doing the audio amplifiers and everything, but I never once forgot this concept. And it was always fun between amplifiers to play with the thing. Mm-hmm. Sometimes it would run for days, sometimes it would blow the transistor, sometimes it would run for a week. So that's when I said, this is what's happening, and I need to put a diode here. And at that time it was a 1N94, I think, 1N94 diode, 914, whatever it was, a little glass diode. And then I found out by reducing this, by making this base resistor from 10 ohms, say to 100 ohms, up to 600 ohms, right, that this started to go faster, which told me something, that something was being relieved from the circuit. So I started looking at all these signals, and I noticed that this signal was sort of like that, and this signal was sort of like this. Let me get these signals where you can see them. That this was generating basically a spike, mm-hmm. and that was firing the transistor. So I knew that you had to protect this base. So you absolutely do need the diode there, or you just burn the transistor out. You know, so I kept watching the signals, and what I saw was things like this. Mm. And when I was watching the scope, I said, and basically, Pat, I had inverted the scope. And so actually what was really happening was this was...
What do you mean you inverted the scope?
Well, I had inverted the scope to look at different signals.
Wasn't a modification that you made?
No.
Okay.
And so I wanted to watch this, right? I wanted to watch it in both inverted and verted, uninverted and inverted signals, right? So this one, this magnet goes by and it generates this pulse, right?
Okay.
And that fires the transistor, and then look where the coil is, it's in the collector. So you know this one's pulling down and going like this. See?
So on the left-hand coil there, the side of the coil, where's that going to? You've got an arrow on it. Where's it going to?
This is the ground symbol.
Okay.
These two are actually connected together. So anyway, I knew that if you put the signal into the transistor and you put a wave into it, a square wave, that this one is going to come out identical to this one, and this one is going to invert itself and come out like that. Mm-hmm. All right? So whatever, they're different. There's two different phases here from the device. But this is sitting at ground, so we're only interested in this one here. So I said to myself, gee, why don't I try this? Why don't I pick this spike off? Mm-hmm. Right? And I said there's only one way to do that. And that's to put a diode here. And now I had this picked off. So I had this 12-volt battery here and I had another 12-volt battery here. Okay, and I started experimenting with this. And this is the first mode of operation where I said, oh, if I have 12 volts here and I have 12 volts here, all I have to do is just bring this negative back up to this positive, and this battery will charge.
Yeah.
So that's what I did. And so now I was running this. The wheel was rotating. I had some power, not much, maybe 20% mechanical or 15% mechanical at the time. And but I was noticing this. Now it was taking a lot longer for the battery to go down from its 12.65 down to 10. Okay, and I never took them down below 10. I just didn't run them until the wheel stopped.
Okay.
All right, because it will run down to 3 volts or 2 volts. And I noticed that the charge was, it took some time to do this because all I was doing was picking off this spike. Mm-hmm. All right, and there was no current there.
Yeah.
There's basically no current when there's just this little spike. So this battery that I loaded down, right, was going like this. And the more I ran this, doing this, the faster it did this. Okay? So now look at the two curves. It's taking a long time for this to go down, and it's charging this one, so I said to myself, just thinking to myself, well, let's add another battery. So I did that. And pretty soon I added another battery and another battery. And it kept taking longer each time. Sometimes this would be running down to 10 volts, and I would still let it run, and I would stop it at like 9.5. But I was always getting this charge back in the battery, even though I had these batteries here. Mm-hmm. So it's like there was no effect to the motor. In other words, there was no current. So the motor it was like the motor didn't see it. Mm. So now I had my motor generator. And that was phase 1 of the SG motor. And so other people announced it, and I announced it, and I was on different radio programs, and I was on Bill Jenkins with it, and with G Fields and stuff like this. And I said to myself, there's other ways to do this. So we've gone to phase 1. You've seen the circuit in phase 1 right here with the 1 coil, right? So later on I said to myself, let's just keep adding coils, multiple coils. So if we could get just a shot of this coil. So you can see here that we've twisted these wires together for 130 feet, and that they're separated, and each one of the coils goes to a separate transistor on here. And each base resistor is independent. So even though it's using the same trigger circuit. So I'll draw that on the board in a second so you understand the multiple coil arrangement and why I thought this way. All right? So basically that's your multi-coil arrangement, and I just wanted to get a shot of this so you could see that it was twisted together. Okay, so anyway, I'm going to go back a little bit here. Once again, I had to figure out a way to get more energy out of the circuit. So as I said in the early part of this, that I had to add more coils, and we've captured a view of the coils on this machine over here. And so now that means that the circuit changes. So now we go from the basic circuit number 1 to a revision, a B revision, which means that now we've decided to add multiple coils. So we'll use 3 for this, but there can be as many as you want there. As long as you have a big enough spool to wind the wire on, you can do this. So that means now that we take each one of these coils and we insert the diode in each one of these coils. As this wheel moves around, these coils are firing at the same time, and we're getting more output yet. So each one of these then is being triggered by a transistor, and the trick to this is, because there's no secret to this, is that in the trigger coil, this still remains at ground. By the way, there's 3 grounds, Pat, that I want to explain to you. There's the antenna ground, and then there's the electrical ground, right? So there's these 3 different ground symbols that you can use. Okay? So you've got the antenna ground, and that's usually associated with an antenna on a coil. And this one's usually associated with the electrical ground. And this one is associated, I think this is the earth ground, electrical ground, no, antenna ground. Now I'm confused. But anyway, there's 3 grounds, and the correct symbol is this symbol for the circuit. It's very hard to remember all this stuff constantly.
So you primarily use just the one for your...
Yeah, I've always used and I don't mind saying this, I have always used in my entire life the wrong ground.
Okay.
Because I liked the way it looked. You know, so I always used this ground. And everybody said, why are you using that ground? I said, well, it's ground. Well, no. You know, so I just, you know, decided to correct myself after many years. I mean, it made sense to me, but not anybody else. But neither here nor there. So anyway, all these tops of these coils can all be connected together. And all end up at the positive of the battery. Okay? And the negative of the battery, of course, is going to end up with the electrical ground. So that meant all these transistors, and each one has a diode to protect it that's to the same ground. And now the secret to this, and there's really no secret to this, it's a matter of what I would call balancing the machine to run its best. So you can select a value of resistor that drives this base, and you could select another resistor that drives this base, and another one that drives this base. All right, and so I've chosen with this particular machine 470 ohms. And now each base is isolated through a resistor, see that?
Okay.
And each coil, right, is isolated through its own output diode. So now we have basically 3 motors running here. with one coil. So you can tie these together, and they're all the same. They're all going to receive the same trigger signal, except for one thing. You want to tune this motor to run at the fastest speed, and this is going to give you one speed here and one frequency. And by adding another resistance in the trigger line, which on this motor happens to be 12 ohms, so you can see it's sort of odd. And that allows this to run at its optimal speed. So this is the revision B to the basic number one circuitry. All right, and that's multiple coil operation. And some people say, well, I'm not getting enough out here. See, it's not important, as I've said all along, it's what you're getting out here. It's what's going on in the circuits. You know, are you heating the circuits? Are you not giving them enough current to run? Are you trying to use a neomagnet? When I said don't do that, that's exactly what I meant. And the reason that I say do not use a neomagnet is the iron pole with the neomagnet is going to saturate completely, and it's not going to be able to break free. It's just because you have a neomagnet here does not mean under any circumstances that the motor is going to be more powerful. In fact, it's going to be weaker. Because you want this at the fastest RPM that you can go. Because RPM equates to horsepower in the end, or a fraction of a horsepower with this. And a neomagnet is going to saturate this, and it's going to take more electrical current from the battery to make this thing spin. So once again, I'm going to point out to everybody that's watching this DVD, do not use a neomagnet. This was not designed for a neomagnet. If you're going to use a neomagnet in a motor, then it has to be an ironless coil. You know, it's just going to be wire. You follow me? Because you don't need any iron. You have a concentrated field with the magnet, and so you don't need to saturate anything. So this is termed an ironless motor when you do this, and you don't need any of these rods. Now, the next little thing that came up is, why did you use welding rod? The reason that I used welding rod, RD60 I think it was because when the welding rod takes the magnetic flux through it and the magnet leaves, the welding rod does not retain any magnetism in it. All right?
The welding rod is what we're looking at through the top of here, right?
Yes, that's what you're looking at. Okay, so now we have the basic revision B to the SSG machine. It's actually an advanced schoolgirl motor with multiple firing stages, all at the same time. And of course you get a little bit more output and you get a little bit more torque up here. All right, so that's revision B. I want everybody to understand that. Okay, now, the next function of the SG is, how do I turn it into a generator? That would be number 2. I want everybody to understand. Number 2 is what I would call a forced mode system. I'm forcing it to generate current.
So this is like phase 2, right?
No, this is revision B.
Okay, revision B. Okay, I'm sorry.
And now we're going to motor number 2. There's 3 operations to the SG. We're on number 2 now. We're going to move to number 2.
Okay.
All right, now. And then what we're going to do here, after the explanations are given, and I know there's going to be a lot of questions. All right, and anybody attending the conference will be able to ask all the questions they want. I mean, I have nothing to hide here.
Right.
Okay, was to revise this multi-pole meaning many magnets around the wheel. Mm-hmm. More magnets, more trigger pulses, more torque on the wheel. Okay. Now, generator mode. Let's just take the simplified version because it doesn't make any difference if it's a multi-pole machine, like over here, or it's just a single coil. You can do the experiment yourself. You saw the first SG machine, and what I'm going to do is not worry about the wheel. I'm just going to put the circuit here. So I think we can get this. So remember I said on the first SSG machine, and the battery of course is up here, between here and ground, okay? On the first machine I said to the second battery, right, there's a primary battery and there's a second battery.
Right.
And what we're going to do then is, that one is the simplest machine to work with as far as getting energy back out. And I said that it returns back up to the positive of the battery, the negative. Mm-hmm. So if you look at this, if you think about this for a minute, you have 12 volts and you have 12 volts. So you can see that it's actually switching back and forth.
Okay.
Okay. If you really want to get technical with it, that's exactly what it's doing, and you can see that because that's off, that's on, this is off, that's on. Mm-hmm. All right. And there's no current flowing at all when the machine, because the two batteries equal. All right. They're going to equal out. Mm-hmm. And so now we have to be able, in a forced condition, to put what the battery wants the most, which is current. Mm-hmm. So that means that we have to look at this circuit a little bit differently. Notice that this wire now is going back up to the positive. So in a forced condition running the SSG, this negative just returns to ground. And now when the transistor switches, it's current. It's going to force the battery to rise upward quick. Okay. So you could put a switch on the machine, and you could go between phase 1 and phase 2 in a forced condition and put a quick charge in the battery if you needed the battery right away without depleting too much of the primary battery. Because remember, it's being pulsed. So it's like this. And depending on the size of this pulse, it's how much current the motor's going to burn.
Okay.
Okay, so if you have narrow little pulses like this, the motor's not burning much energy. Okay. But in a forced condition, you're not getting much energy either. So you want a wide pulse in this condition because you want to force. What you want to do is you only have so much time with this battery here to do what you have to do before it's downhill. And so what you want to do is you'd start at this level and you want to go as quickly as you can pushing that battery up. Because don't think for a moment that the battery can't absorb that charge. Mm-hmm. It can. So this would be phase 2. Okay, number 2. And that would be forced charge. That's phase number 2. Phase number 3 can be something to desulfate batteries and put a lot of energy in a capacitive discharge. Bang, we're going to charge that battery. So phase number 3 is going to be where I take the machine, same circuitry once again. So now I'm going to do something a little bit different because there's 2 phases to this. All right? And I want everybody to pay very close attention because this is important in what can be done. If I take phase number 3, phase 3, right? And I run this to a capacitor between here and ground. I'm going to get the most charge in this capacitor because I have current. All right? So I want everybody to understand that you're dealing with current here. And what you really want a battery to do is you want it to rapid charge. So you would put this into the capacitor to ground. If you weren't so much interested in a rapid charge and didn't want to burn much energy, you would take this capacitor and run it back up to the positive. And now you have the SSG machine charging a capacitor. Now this capacitor is going to raise...
SSG being simplified school.
Yeah. Schoolgirl motor that's more advanced.
Okay. So how is more advanced simplified?
Well, it's not simplified. I mean, it's a simplified drawing.
Okay.
It's not really
He's
simplified.
asking why it's SSG.
Well, that's just the name
Okay.
of it. And I didn't really name that.
Okay.
To me, I'm just going to explain what can be done and what can't be done.
Yeah, okay.
And why you fail and why you don't fail.
Yeah.
All right. So anyway, now we're not supplying as much current because we're going back up here to the positive. So that means the capacitor charge time is going to be a little longer before it reaches its peak, where if I did it the other way, it's going to go like this. See? And if I put it in a forced generator condition, I'm forcing the battery to go from here to here like this, quickly, and then take its time going up. I'm trying to get it to get going.
Yeah.
So I'm in a generator mode. All right, so that's all fine and well. Understanding this part of it. The next part of it is very important because what you have to be able to do to charge the battery, this battery, which was a secondary battery, is to build something that can detect the charge on this capacitor. So that when this capacitor reaches a level, say I pick a point, say I pick this point, and then it discharges. And the only way to do that correctly is with comparators. You know, and I've been through this once with people, but they don't seem to get the absolute concept of it, or they're trying to second guess me in what I built. You know, they're not coming directly to me and saying, geez, what did you do? Because what I did was totally different than what they're building on the internet. Anyway, I can pick my points of where I want this thing to discharge
Okay.
as this capacitor charges up. So I can pick any one of these points I want. Now, this has to do with time. Time, very important. How much time am I going to give that capacitor to go up to here?
Okay.
So this is time. And where in this time am I going to tell it to discharge? Well, I'm going to make this very simple for everybody. It depends on the situation that you're in and the batteries you're using. There is not one single formula to know exactly where the time is for this battery.
Mm-hmm.
Don't, by no means, and that's everybody, say, I'm going to use this little bitty battery that's 1.5 amp hours and expect to run the machine. It's not going to work. You know, and I'm going to charge this other little bitty battery. And why did you buy that battery? Well, it was cheap. That's why you bought that battery. Mm-hmm. You think that you're going to be able to see how quickly this does this with these little batteries, but you're only short-circuiting yourself. Mm-hmm. You want something that can give you time to study it.
So what sort of size of battery would you say?
13 amp hour minimum, which is this actual battery that we'll be filming in a minute.
Okay.
Okay? So, now I've said to you that I can choose my time. So that means that by choosing this time, I have 5 volts here, I have 10 volts here, I have 20 volts here, I have 35 volts here, I have 50 volts here. Okay, now the next thing is how much time is it going to take to charge the capacitor that you choose? Now don't use too small of a capacitor because that's not going to give you what you want. So I would say minimum capacitance, 15,000 UF. Well, I can't charge that. Yes, you can. Because when we go over here to the demonstration,
15,000 what?
microfarads.
Okay.
Sorry about that. UF, I put the symbol here.
Yeah.
Okay. And at least you have to at least have, 15,000 microfarads at 75 volts, because what's going to be generated here is this. Remember this spike peak that's high voltage. So this amounts to about 300 volts.
So is it a matter of 15,000 is good, 20,000 is better?
Well, I'm going to explain that in a minute.
On that?
That depends on how you build the circuitry to the machine.
Okay.
All right, that's a good question, because there isn't one set thing for that. All right, so now we know phase 3.
Right.
And phase 3 is using a comparator that's basically going to do this.